Hello. Yeah, good morning. I'm K. Mukherjee. I got a couple of requests from my students to explain this Pyomo. There's several companies nowadays using Pyomo. Pyomo is it's a uh, you know it's very flexible, just like do simplex package or pulp. Now with the Pyomo, you can do the stochastic as well as this nonlinear programming. Now, what is this Pyomo? So I managed to get a book. It's clearly mentioned that is Pyomo is Python optimization modeling objects. Okay. Now let us come to let me check whether it has been shared or not properly. Okay. So on the top you will get what I'm doing. That is this is Pyomo. Pyomo is basically with the help of this Pyomo you will write or you will prepare the mathematical model using this Python. So on the top, I have written this Pyomo VRPTW. I have taken the simple vehicle routing problem with time window, that is Solomon or workbench problem, and OOP, that is object oriented programming concept. In the first one, what I have done, it is a simple class I will prepare, I will show you. And in the class, I will include the model as well as its the objective functions and its constraints. And in the next model, I will show you how to use this decorator. Now, only one book is available, to learn the Pyomo means how to use it. But in that book also, I didn't find that is, use of this decorator means how to use this class and object-oriented programming concepts. So that's why this tutorial will be meaningful if you are willing to learn Pyomo. So on the top, I am doing that is import platform and platform.architecture. And after that, I'm just checking that is whether your computer or this laptop or the desktop is 64-bit or not, because this is required. If your simplex is 64-bit compatible, then this is a must. You must check it, otherwise it will throw error. Now after that, I am importing pandas, numpy, and then I am checking whether this py means pymo has been loaded properly or not. So I'm using this try except block. Within this try, I'm like writing this from pymo dot environment import all, and this pymo version, that pymo dot dunder functions, that is double underscore version double underscore. And if you don't have this pymo, then it will throw an IO error, input output error, and it will write there is PyMo not available. So if you run this one, so it will show you that is the PyMo version is 6.6.2. Now after that, I'm creating a class that is called the solver attribute. I don't open it much. It's basically a meta class. Now purpose of this meta class, is to control the data struct means data type, or if the input data are wrong, then in that case it will throw error. So initially I'm not including in this next video, you will get it. So the next thing is what I'm doing, it is basically a VRPTW solver. I think we need to we need to increase the font size a little bit. Now let me check whether it has been shared or not. Otherwise, okay. So what I'm doing, say in this class, name of the class is VRPTW solvers, and I mentions every class, it inherits this object. So object meta class, I'm mentioning this type. So if you prepare this meta class, I have prepared the meta class here. So in this case, the meta class is equal to solver attribute once you completed this coding. So what I'm doing basically, the VRPTW solver class. It is this init functions. In this init functions, I'm passing this data. It is basically a data frame. Max capacity of this vehicle, it is basically given this 200. And then instance name, I've given this VRPTW. There is Solomon workbench problem C101. Now self.data, I'm passing this data, self.customers. This is the I for I in range of one length self of data. So it will create a list of customers. Then I'm just printing how many customers are there. That is the length of self.customers. Then I'm creating the vertex. So vertex is basically including the 0 plus the number of customers starting from 1. What is the concept of this 0? 0 is basically the depot. It is a, the closed loop via PTW problem means the vehicles will return to the depot after traversing different places. Then I'm creating a dictionary, that is self.c is a dictionary, and here I am populating the self.c with a function. It's known as the distance matrix. So what is this distance matrix? Let's see. See here, I have created defined a distance matrix self for I comma j in self.arc. We are creating an arc, and self.c, this dictionary is populating I comma j, that is from ith node to jth node. If the vehicle is moving, so how much distance it will traverse. So it is equal to self dot underscore distance, that is a private functions, that is self customer 1, customer 2, customer 3, this way. And it is returning after populating the dictionary, it is returning the dictionary. So this is basically, you will see that is a self dot distance matrix. After that, I am just calculating this self dot vehicle max capacity. So it is transferring this value 200 here. Self dot ready time, from the data I am taking this ready time and converting it to this list. Due date, self dot due date to list. Now I'm creating the model. Whether you are using Pyomo, PALP, MIP, or any kind of duplex, the fundamental concept is you need to create a model. Now in this Pyomo, we have these two models. One is a concrete model, another one is this abstract model. In the abstract model means we are creating this math model, but we are not including the data. The data is a separate, means you need to fit the data separately, and you need to create this data with a proper format. So I will discuss this later on. So self.model, concrete model, I'm giving this instance name, then self.model.arc. So in this model, I'm just passing arc. Arc is basically here, it is attaching with this model. It is basically set. Now, when we are preparing this math model, everybody knows that is generally we prefer to create this set theoretic approach. That is, a set is basically the collection of arc, all the arc. Now, what is this arc? If you check here, we have created this arc, that is I comma j, for I in self dot vertex, for j in self dot vertex, if I is not equal to j. So once you are creating this set, a set with the self dot arc, then you are creating the self model dot distance. It is basically a parameter. Now self dot model dot arc, you are passing this parameter and initialize self dot c. Now here the question arises in while you are learning this Pyomo, what is the difference between this parameter and what is the difference between the variable? Now if you check this carefully, parameter is taking two indexes, because this model.arc, it is taking the two indexes I comma j. So the distance self.model.distance is a parameter. It is taking these two indexes I comma j, and it is initializing this one. Initializing means you are giving this value with this self.c, that is basically a dictionary. Similarly, you are creating a parameter self.model.maxCap, that is the parameter initialize self.vehicle.maxCapacity. Here, we are not indexing it, just you are passing the value. Now, after that, we are creating a set, that is self.model.cast, that is set initial is equal to self.customers. Okay, we are creating the set of customers. Now self.model.x. Now self.model.x is basically a variable var. It will take the indexes self.model.arc And what type of variable it is? It is basically a binary variable. Now, what is exactly the binary variable? Say, for instance, you are traveling from node I to node J. If the vehicle is traveling from node I to node J, then this binary variable xij should be equal to 1. Otherwise, it will be equal to 0. Now, we are considering another variable this. This is equal to u, self.model.u. This is equal to var, self.model.customer. So it will take the indexes of the customers. Okay. Now, what is the indexes of the customer? Only one index. And when you are taking the self.model.x, it is taking self.model.arc, means it is xij. And here the ui. Okay. Now, within, what type of variable it is? Real. What is the bound? That is a self dot underscore upper bounds. Okay. Now we need to find out what is these bounds, and we are passing this self dot underscore upper bounds. So upper bounds. So here, if you check, I have created a function that is self underscore u underscore bounds is a private functions. It is returning. So it is taking this, the argument model. So, and it is returning this 0, that is the lower bound is 0, and the upper bound is self dot model dot max underscore capacity. So the value of u will be between 0 to 200. Okay, because max capacity is 200. Now after that, what I am doing, say self dot model dot time 2, that is var. So it is taking this upper bound, that is self dot vertex, and the self dot model dot time 2, it's a variable. Its index is 1. The vertex starting from 0. Bounds is self dot underscore time 2 underscore bounds. So time 2, as usual, if you check here, so yeah, this define underscore time 2 underscore bounds is a private function, that is self model, and this I is this index. So it will return self dot ready time I, self dot due date I. So what is the meaning of this? Now ready time and due date is basically a list. If you check in the code, the ready time and the due date is basically, see, self dot due date, self dot ready time. This is basically a list. We are reading the data, the field is ready time, we are converting it to list. We are reading this due date, we are converting to this list. Okay. Now after that, what we are doing, now these variable time too, this is very important. Now its bounds will be, from a list, there is a list, the corresponding elements. Its bounds will be in between the ready time and the due date. That is here, that is ready time. This is ready time and the due date. Now, if you, those who are, those who are using this do simplex, here you will get little bit difference, because in this do simplex we are directly passing this index using this for loop. But in that case, what you are doing, we are creating the bounds, and in this bounds we are passing a function. In the function we are passing this index and this model, and it is automatically taking. Now similarly, self.model.depart. So this is a variable. It is taking, vertex, and within non-negative reals. Non-negative reals means depart time should be greater than equal to 0. That's all. Now we are creating a self.model.objective, instantiating this objective. Now we are considering another one is self.status. It is equal to none. The status means basically during these optimizations, we need to check whether we are getting optimal solution or, unbounded solution, or this invisible solution, etc. And after that, what I am doing, I'm creating the constant 1, constant 2, constant 3, constant 4, constant 5. Self.model.constant 1 is basically the least of constant. So constant least we are instantiating. Similarly, self.model.constant 2, constant least, self.model.constant 3, constant least, self.model.constant 4, constant least, self.model.constant 5 is a constant least, and self.solver, we are considering initially none. This is a variable. Now let us come here. What is the the function. Let us consider here. Now, define underscore constant one, that is self. Okay. What I'm doing for I in self.model.customer, I'm using an I loop. I'm using this left hand side. Left hand side is equal to sum of self.model.x, that is sum of xij, sum of xij for j in self.vertex. Means for every I, you are summing up the xij with respect to j, where xi is not equal to j, and right hand side is equal to 1. And after that, what you are doing, that is self.model.constant 1. What is this constant 1? Is basically a list, okay? And in this list, you are adding, the constant one by one. So just like in this list, what we do, that is list dot append generally. In this case, what we are doing, that is self.model.constant 1, then add left hand side is equal to right hand side. Now, similarly, I'm defining another constant, that is a constant 2, that is for j in self.model.cast. Left hand side is sum self.model xij for I in self.vertex. Means for every j, you need to sum with respect to I, then vertex, that is for I in vertex. Means for every j, summation of xij with respect to I, right hand side is equal to 1, then what you are doing, the self.model.constant 2 dot add left hand side equal to right hand side. Now what you need to do, that is you are defining the constant phi for I comma j in self.model.arc. If I is not equal to 0, j is not equal to 0, expressions, we are creating an expression. Okay. Now this type of, affine expressions you can get in this do simplex also, in MIP packages also. So in pulp also, that is self.model UI plus self.data demand I log j minus of 1 minus self model xij multiplied by this big M less than equal to self.model uj. Now, what is this ui and uj? Ui and uj we are considering, that is these expressions we can use, that is for the cumulative demand. For instance, the vehicle is moving from ith node to jth node. So what will happen? That is, what is the cumulative demand at this ui? Okay, plus when you are moving to the jth node, so the demand of the jth node should be less than equal to the self.model.uj. Now, here we are using a big M formulations. Big M formulation is like this. That is, if self.model xij is equal to 1, then this term is equal to 0, then self.model ui plus self.data demand at this jth location should be equal to less than equal to self.model uj. Now, next is constant number 4. What I'm doing, that is I for I in self.model customers. I'm taking each value of the customers. Left hand side is equal to self.model time to I plus self.data service time I log I. Right hand side is self.model depart I. Then left hand side should be less than equal to right hand side. What is this meaning? Now you are reaching, the vehicle is reaching at port number I, okay, or the customer node number I, then it will, unload something, or it will give the service to this customer. So it will take certain time. So these summation of these two should be always less than the depart time, because because when it is departing from this customer node, so arrival time plus service time should be less than equal to the departure time from that node. And the next constant number 5, what I am doing, that is for I comma j in self.model.r. If I is not equal to j, j is not equal to 0, Left hand side is equal to, I'm considering self.model.time to I, self.data service time plus self.cij 1 minus self.model xij multiplied by this. What is the meaning of this? See, for instance, you are traveling from ith node to jth node. If xij is equal to 1, then you will travel from ith node to jth node. In that case, what will happen? That is uh, arrival time at the ith node plus the service time at the ith node. So if you sum it, that is the departure from the ith node plus the time taken to traverse the distance. Now, if you check this Solomon workbench problem, that is they are considering the 60 unit, means the traveling speed they are considering, that is a 60 unit per hour. Okay, so that's why so these distances basically, this distance is basically corresponding time unit. Means what I want to say, that is if you check this Solomon this one, how much time it is taking to traverse this distance, how much time it is taking to traverse this distance, it is basically a time unit, 1 unit if you consider, so it's basically a time unit. Then 1 minus self model xij multiplied by this big M. Then right hand side is equal to the self model time j, means from ith node to jth node, if you are traveling, the time depart time plus the time taking to traverse the distance, then the big M formulations, then right hand side. So left hand side should be equal to right hand side. You are just adding it. Now we are creating next a defined solve. In that case, what I am doing, that is self.model.objective. I am calling that is self.objective expressions. So what is this objective expression? Let's see here. Self.objective expression. So this is the self.objective expression. So if you check here, return objective expression is equal to sum Cij multiplied by Xij. Sum of Cij Xij. Okay, for ij in self.model.arc, sense is minimize Cij Xij. So you can check my other tutorial, means to check this entire math model, and then you can go through this modeling approach, so it will be clear to you. Now, if you check this one, that is we are creating this objective expression and passing it to self.model.objective, then we are passing the constants. We are calling the constants. Number one means to create the constants, a list of constants. We are calling constant number two to create the list of constant. This way, constant 3, constant 4, and constant 5. So you can check, if you forget this one, you can check here. That is basically we are calling this function constant number one, then constant number two, and populating this model dot constant number two. Model dot constant two is basically, constant list. In this case, in actual list in Python, we need to append. In this case, you need to add. Okay. Now, after that, what I am doing, that is, we are calling this self.check math model. Now, check math model means here you can check, this is the math model. If verbose equal to true, means if it is true, so it will print the objective expressions, then such that self model constant 1, constant 2, constant 3, constant 4, constant 5, this way. Only I'm considering only fast constant, so that's why I'm giving this index 1, and after that I'm giving the dot expr expression. So in the pal you will in the Pyomo you will get these two things, that is the body and the expression. Say for instance, ax less than equal to 1, so this is this expression. If you say this body, you will get only ax. If you say this expression, you will get ax less than equal to 1. So that's why I'm giving this expression, so that you could get this complete expression. And what I'm doing, I'm reading this data. Then I'm saying this solver, instantiating this VRPTW solvers. I'm passing this data, that is the pandas data frame. Then the solver object which is this object of this class VRPTW solver, solver.solve. So it is solving, and at the same time you can check. First, it is printing the entire expressions, objective functions this way, entire expressions. This is the objective functions is going on. And see, these are the block subject to. Now these are the constants. This is the constant number one. This is the constant number one, constant number two, this constant number three. This way, only the first constants we are printing. Otherwise, it will too big. Now, after that, it is solving, and finally, see, this is when we are solving. So I'm using here the SCIP. This is the fastest solver. So you will get finally the result. The problem is solved. And these are the node, means it's from the depot, it is going to node number 5. Then if you check this from node number 5 to node number 3, and node number 3 to node number 7, then node number 7 to 8, then 8 to 10, then 10 to 11, 11 to 9, 9 to 6, 6 to 4, 4 to 2, 2 to 1, and 1 to 75. So it's a long trip basically. Then from 75, let's see is from 75 to 0, means again it is terminating to this port. So when we are, this is a simple approach, but when we are using the decorator, the function decorator, means we need to understand what is this decorator. Decorator means we are passing a function as an argument to a functions. Okay, so in this case, what we are doing, that is from pyomo.environment import all, import pandas as pd, import numpy as np. From pyomo.opt optimizations, import solver status, termination condition, import logging, because we need to log everything. And then what we are doing, this is very important, I didn't find in any book, I checked thoroughly. That is from pyomo.util invisible, from pyomo.util.invisible, import log invisible constants. Because say you have prepared a math model, but during this running, after running this model, you are getting this statement that it is an invisible problem. So if this problem is invisible, in that case you can log it. There's facilities is given to this pyomo, that is pyomo util invisible, Pyomo util invisible, import log invisible constants. And in this log invisible constants, you can give the path where you can log this constants, the constants, those who are conflicting constants, okay, or the contradicting constants. Say, for instance, you are saying x1 plus x2 plus x3 less than equal to 10, okay, and at the same time you are saying uh, x1 plus x2 is x1 plus x2 plus x3 less than equal to 10, as you said. At the same time, we are saying x1 plus x2 plus x3 is greater than 10. So this will contradict, isn't it? Because of the right hand side is one is this less than equal to, another one is greater than. So when you are going to use the decorator, just keep in mind everything should be within this init. I will show you now. So what I'm saying, that is the class VRPTW, the class name is the deco object, meta class is type. I didn't include this meta class so far to control the variable. So sale data is pandas data frame, vehicle max capacity is 200, instance name is given C101. So you can create a model, the concrete model, pass the instance name, self.model, you can mention the data. Then what you are doing, see, you are saying this self.customers for I in range 1 comma length self.model.data means what is the length of the data, and we are creating the customer from 1. Okay, then I'm printing how many customers are there. As usual, I'm creating the self.model.vertex. Now what is this vertex? Vertex will start from 0, that is the depot plus self.customers. Okay, next I'm creating this arc. Arc is basically connecting node 1 to node 2, node 1 to node 3 this way. So I'm creating a tuple I comma j for I in self.model.vertex, for j in self.model.vertex if I is not equal to j. Now the next thing is I'm creating a dictionary self.model.c. Then I am populating this dictionary with the self.distance matrix. I'm creating self.vehicle max capacity. This is the variable. I'm transferring the value here. Vehicle max capacity is 200. Self.model.ready time, that is self.model dot data ready time to list. I'm transferring here. Self.model due date, self.model.data due date to list. I'm transferring here. Self.model.arc. Now I am creating a set initializing the self.arc. Okay. Then I'm creating self.model.distance. I'm creating a parameter self.model.arc means for indexing, and then initializing it with the dictionary self.model.c. Now self.model.maxcap, that is it's a parameter initializing with self.vehicle max capacity. There is no indexing. So for this max capacity, for the distance, you can say the model.arc means self.model.distance I comma j. This way the indexing would be. Now I'm creating the set of customers, self.model.customers, self.model.x. The variable is a binary variable I discussed earlier. So its index is I comma j, self.model.arc. That's by taking self.model.u, that is a variable. I am taking the self.model customers within real. This is a continuous variable. Bounds self._u underscore bounds. So this is a function I stated earlier. So self model.time 2, this is a variable. It is taking the vertex for indexing. Bound is self._time 2 underscore bounds is a private function. This is also private function. Self.model.depart is another variable. So it is taking the vertex index, and I'm taking self.model.status. It is none. Now what I will do, so I have mentioned you need to write these objective functions and the constant within the init to using the function decorator. Okay, so I'm creating this objective function. So self.model.objective, self.model.objective. I'm defining this objective as as, not self, as is an index. The sum is dot c, just like is you can consider a self. So is dot c, c is the dictionary. Okay, c is the dictionary I discussed just now. So this is a dictionary. Okay, so c I comma j, that is the c index, is dot x is the binary variable x I comma j for I comma j in s dot r. Okay, now I need to create a constraint. So what I will do, self dot model dot constraint. So self dot model dot custom. So self dot model dot constraint, if you recall I earlier constant, that is I'm defining a constant that is s comma I, that is this index, that is this left hand side, sum x ij I comma j means sum of xij, summing xij with respect to j for every I, and this I index will get it from here, that is I for every customer, self.model.customer, and right hand side is equal to 1, and returning what, left hand side equal to right hand side. So the constant will be automatically created. Similarly, here you will get, I'm creating this at the rate self.model.constant, self.model.customers. I'm taking this index, that is model.customers. Now I'm creating this self, defining a constant to s is nothing but you can consider as a self. Now j is this index. Okay, now what you need to do, for I, see for instance I, for every I, similarly for every j you need to sum xij. So s dot xij for I in s dot vertex if I is not equal to j. Sum of xij with respect to r I, sum of xij with respect to I for every j, and right hand side is equal to 1, so left hand side is equal to right hand side. Now, constant 3, self.model.constant, self.model.arc. I am taking this argument, that is self.model.arc. Arc means I comma j. Okay, so s comma I comma j. If I is not equal to 0, j is not equal to 0, so return s.ui plus s.data demand I log j, then begin formulation 1 minus s xij multiplied by this begin less than equal to suj. Else return constant dot skip. This thing is why constant dot skip is required. If you do not give this constant dot skip, then what will happen if I is not equal to 0 or j and j is not equal to 0? This will loop will occur. Okay. Now, if I is equal to 0 and j is equal to 0, in that case, it will escape from this loop, but it is not in position to understand what to do, so it will throw the error. So what you need to do, in that case, you need to write the return constant dot skip. Okay. So here you can check. Okay. Now, similarly, in the constant form, what you need to do, there is self.model.constant, self.model.customer. What index you are considering? I. Means in earlier what we did, for I in this, if you check this constant number 4, if you check this constant number 4, say for I in self.model customers, then left hand side, right hand side, then within this for loop we are adding self.model.constant 4 that add left hand side less than equal to right hand side. But if you come here, that is constant number 4, what I'm saying, that is self.model.constant, self.model.customer. Okay. Now define constant for s comma I. Left hand side is s dot time to I, s dot data service time, I log I, and right hand side is s dot depart I. It means the arrival time plus the service time at a particular node should be less than equal to depart time. What index we are considering? I. I index is coming from self.model.customer. Now, if you consider the constant number 5, self.model.constant, self.model.arc. So for this arc, we need two index, I comma j. So if I is not equal to j and j is not equal to 0, then left hand side is time dot to I, is dot data service time I log I, is dot c I comma j, 1 minus s dot x I j multiplied by begin. What is saying, that is you are moving from ith node to jth node, that is arrival time plus the service time. This total is the depart time plus the time taken to traverse this distance minus 1 minus begin. That is begin if xij is equal to 1, so this term is equal to 0. And right hand side is s dot time to j, and left hand side less than equal to right hand side. Now, if I is not equal to j, it is okay. This loop will be executed. But if I is equal to j, in that case, you need to write constant dot skip. Otherwise, it will throw, the error. Now, the distance matrix when you are creating, that is self.customers 1, customer xy, customer 2 xy, we are directly taking, self.model.data, x coordinate, y coordinate, x coordinate, y coordinate this way, and I log passing this I comma j this way. And we are creating distance matrix. We are calling this, private function, a private method. Here we are passing I comma j from this arc, and we are populating this distance matrix. One thing I should say here, this is a, benchmark problem for the testing of your code, or if for learning process, it is okay. But in maximum cases, we don't create this distance matrix this way. The distance matrix, from the database on the tabular format generally we get. Then we are saying this is the upper bound, and this is these, bounds are given. Then we are checking the expressions, means what is this expressions I discussed earlier. Now, when you are going to solve, so define solve, self.solver. Okay. Now, solver factory. Solver factory means Basically, in the Pyomo, you can use the different solver like the Ciplex, like Gurobi, like SCIP, GLPK, and any other solvers also, GAMS, etc. Now, in this case, what I did basically, I use this SCIP. So I'm giving this name of the solver is SCIP. Executable means the location of the path. Now, this is also I didn't find in this book. Only one book is available. I didn't find that it means how to pass the solver path. And when you are using this GLPK, you can write his GLPK here, and there is no need to give this executable path. It can automatically find. If you have the GLPK, then I am giving this self.solver.options the time limit 60, self.solvers.options limit or gap 0.1. Then self.results, if there is self.solver.solve, that is the self.model, self.solver.solve, because you are solving. Self.solver means you have created this factory, solver factory. Now you solve it. You are passing the self.model and t equal to true means you will check display. Self, that is the self.results. Now what is very important here means you need to write the LP file. So how to write it? There is self.model.write. Now, this is the path I have given. You can write this LP file. Now, one thing I need to mention here. Now, when you are using the Pyomo, you can generate the LP file this way. Definitely it will write. At the same time, when you are using MIP package or the do Ciplex, you can create the LP file. But when you are generating the LP file using the Pyomo, the LP structures, the structure of the LP file will be different. And for this, when you are using this do Ciplex, the structures of the .lp file will be different. To be very honest, when we are using this do Ciplex package, in that case, readability of this LP file is more. So I will show in this next video. If I get any request, I will definitely show that is what is the structures of the file generated by the Pyomo and the LP file generated by the MIP package or the DoSiplex. So now what I'm doing, that is if self.results here dot solver dot status. Okay, I need to check the solver status. The solver status dot okay. So what I did, that is from here I imported, that is from Pyomo dot opt optimization import solver status and termination condition. So this solver status dot okay, if it is the solver status is okay, and if you write the self.results.solver dot termination underscore condition is, I need to drag it a little bit, just a minute. Yeah, this is, if you check, that is the termination condition dot optimal, then you can check, yes, this is optimal solution. If else if self.results.solver dot termination under condition is equal to termination condition underscore infeasible, that is for the check for infeasibility. You must check this infeasibility. Means if you are getting any infeasibility, so this loop will be executed. So it will print, yes, this is infeasible. It is not, you should write it as infeasible problem, not the infeasible solution. It is infeasible problem. Then you can write, then what is this thing? Log infeasible constants. So what is this log infeasible constants? Now from Pyomo dot, that is from Pyomo dot util infeasible, from Pyomo dot util infeasible import log infeasible constants, and these log infeasible constant method here you can write, that is what you need to write, that is self dot model log expressions equal to true, log variable equal to true, okay, and variables equal to true. I have I'm also using this logging. So import logging. So logging.basic config file name. This is the log file. So if you are getting any infeasibility, encoding UTF level logging info. Okay. Else print solver status self.result solver status. Then what I'm doing basically, if it is solver status is okay, it is feasible, or here instead of this print statement you can just else, you can type this pass, it will work. And then for I comma j self.model.arc, if now I need to print the value of this xij. So what I will do, that is if value self.model.xij greater than equal to 0, means if the value xij is equal to 1, then it will print, that is xij is equal to 1. Then finally I'm printing the distance traverse. How much distance traverse? Now value self.model. Now this obj. Now this is, what is this obj? Obj is this function, the name of the function, objective function. Okay. So value is self.model.obj. So this will be the value. Now you are reading the data, you are passing it data those this is VRPTW.solve. Now once you are solving, see these are the SCIP output. Okay, and this is the SCIP output. So you can check here, problem is solved, optimal solution found, and primal dual, that is optimal solutions you are getting, that is x015 this way. And finally you will get the distance traverse is 829.00. So if you also here you can check this is the distance traverse. So in this method there is, we showed you how to use the decorator. This is the standard approach in different company. You will find people are using this approach. Another thing you can do, that is you can say that is class VRPTW or decorator. This object, instead of this object you can directly inherit the concrete model. Okay, so once you are inherit the concrete model, in that case no need to, the self dot model will be replaced here. So this is another approach you can do. You can use directly the concrete model, you can inherit and you can prepare. Now this code is really not available. I didn't find any in this book or anywhere, so I prepared it for you so that you could check. It will be available in my Git repository. You can check it. You can download also this code and you can learn if it is required. And another thing I need to show you, that is, as I told you, this is VRPTW decorator. Acha. So these, let me show you how it is writing. So this is, let me share this one. See, when you are using this Pyomo model, the objective expression, that is min plus plus this way, you will get the objective expression. And this way you will get the constants. You can check here. This way you will get the constants. This way you will get the constants. Whereas in case of this do simplex, what you will get, this do simplex, the LP file readability, when you are creating this LP file readability, this is far better because it you will get, a complete row this way is equal to 1. another complete view this way. So that's all in brief. And if you have any questions, you can definitely ask me. Okay. And thank you very much for your request.